Today we are going to start the new chapter, chapter number 11, that is area related to circles. Okay. So in our earlier classes, we have already studied the methods of finding perimeters and area of simple plane figures like rectangle, square, parallelograms, triangles, circles, right? And in our daily life, we come across many objects which are related to circular shape in some form or in some other form, right? Like, for example, if you see the wheels of the cycle, wheels of arrow, right? Drain cover, bangles, right? Flower bed, circular path, etc. They are in a circular shape, right? So the problem of finding the perimeters and area related to this circular figure is of great practical importance, right? Okay. So in this chapter, what we are going to discuss, we will discuss the problems on finding the areas of the two special parts of the circular region, which is called sector and segment of a circle, right? We will also discuss problems on finding the area of some combinations of plane figures involving the circles or the part of circles, right? Okay, so let's quickly see like what are the concepts which are related to the perimeter and the area of the circles, right? Which we have already done earlier, right? So as we know that any circle is what? It is the locus of the points which moves in a plane in such a way that its distance from a fixed point is always same. Yes or no? Right? So we can draw a circle here. So this is a circle, right? Okay, so this is a circle. Now, for this circle, we have circumference, right? Area of the semicircle, and area of the quadrant of a circle, right? So you can see a circle here, right? Okay. So now let's see what are the different terms related to this, right? Circumference. Circumference is the length of the boundary, right? Which is equals to 2 pi r. Okay. Or pi into d, right? Okay. Then if we talk about the area of circle is pi r square. Okay. Pi r square, or it can also be represented as 1 by 4 pi d square. What is d and r? R is the radius, right? And d is the diameter of the circle, right? Then the area of semicircle is area of this part, right? Area of the half of the circle, and this is equal to half of pi r square, right? Okay. And the fourth is area of quadrant of a circle. If we want to find out the area of the quadrant of a circle, then we can also find it as 1 by 4 pi r square, right? This is the fourth part. You can see, right? Suppose if we have this line here, right? So now the area of this one is the area of the quadrant. This is the quadrant. Is that clear? Please write down.
Yes, ma'am.
Now look at this figure. You can see that there are two concentric circles which are shown in this figure. There are two concentric circles, right? So one circle is inside the other, right? And their radius are small r and capital R, right? So these are the radius of the two concentric circles. Now let's see what is the area enclosed by two concentric circles, right? Okay. So what is the area enclosed by two concentric circles, right? So if capital R and small r are the radii of two concentric circles, then the area enclosed by these concentric circles will be given as pi r square, which is the area of the outer circle, minus pi small r square, which is the area of the inside circle, right? So if we subtract them, we will get the area enclosed by the two concentric circles, right? You can take pi common, r square minus capital R square minus a small r square, right? You can also write it as pi. Now, since this is a form of a square minus b square, you can write it as r plus r and capital R minus r, right? So in this way, you can find out the area enclosed by two concentric circle, where pi is 22 by 7. This is a constant, 22 by 7 or 3.14. Now, let us see sector of a circle and its area, right? Consider this circle as you can see here in the diagram. And the radius of this circle is suppose r, O is the center. Okay. Let AB, here AB and C, right, be the 3 points, right? Suppose these are the 3 points on the circle, right? As you can see here. The area enclosed by the circle is now here divided into two regions, right? So what are the regions? Regions OBA, okay? Regions OBA means this region, okay? This is region OBA, right? And OBCA. OBCA means this outer one, right? Okay. So these regions are called sectors of the circle. Is that clear? So this is a sector. This is also a sector of the circle, right? So these are the two sectors. Okay. And each of these two sectors has an arc of the circle as a part of its boundary, right? So this is an arc which is part of the boundary, right, in this sector. And similarly, this another arc is this one, this here to here, right? Okay. So both the regions are having an arc, which is the part of the boundary, right? Okay. Now, the sector OBA, if you can see here, the sector OBA has an arc AB, right, as a part of its boundary, whereas sector OBCA has an arc ACB, right, as the part of its boundary, right? These are the boundaries of these sector, right? Is it clear? Now these sectors are called minor sector and major sector of the circle, right? So which is the minor sector? This one, ACOBA, is the minor sector, okay? Whereas the bigger one is the major sector of the circle. Is that clear? Minor sector and major sector of the circle. So what is the minor sector? What is the minor sector? Minor sector of a circle, or you can say a sector of the circle, is called a minor sector if the minor arc of the circle is a part of its boundary, right? Okay. So here OBA is the minor sector, right? And major sector is OBCA, right? So a sector of a circle is called the major sector if the major arc of the circle is the part of its boundary, right? Okay. Now, there are certain important points which we need to remember here, right? So these important points are that a minor sector, please write down, a minor sector has an angle theta, okay, subtended at the center of the circle, okay? Whereas A major sector has no angle. Okay, right? So if you can see here in this diagram, right? So this minor sector is subtending an angle theta. So you can see here, this is the angle theta, right? Which this sector is subtending at the point O, the center, right? Whereas the major sector is not subtending any angle here, right? Okay. So these are certain important points which we have to learn. Now, another point is the sum of the arcs. The sum of the arcs of major and minor sectors of a circle is equal to the circumference, right? Equal to the circumference. Why they are equal to the circumference? Because both are the part of the boundary only. So if we add them, this is equal to the circumference of the circle, right? Then sum of the areas, the sum of areas of major and minor sectors of a circle is equal to the area of the circle. Is equal to the area of circle. Means if we add the area of the two sectors, minor and major sector, then we get the complete area of the circle, right? Okay. And the third and the fourth point is the boundary of a sector consists of an arc of the circle and the two radii, right? So it is always have the boundary which are two radii, means there are two radius which bounded that sector, right? So these are the points which we should know, right? Now, coming to the area of a sector. How to find the area of a sector? So put the heading, area of a sector. Now let's see what is the area of a sector. Now you can see a figure here, right? Now let's find out like how we can relate this area, okay? Let OAP be, okay? OAPB, OAPB, right? Is a sector of a circle with center O and radius R, right? So let OAPB, right, is a sector, okay, of a circle with center O and radius R, right? As you can see here in the diagram, right? Now let the degree measures angle AOB, right? You can see here angle AOB, this, right? This is suppose theta, okay? This is theta. Now, as we know that area of a circle is pi r square, yes or no? Area of circle is pi r square, right? Okay, and means of a circular region or the disk we can see here is a pi square, right? Now, in a way, we can consider this circular region to be a sector forming an angle of 360 degree, right? So if we increase the sector, right, means the degree measures 360 degree at the center O, right? So how we are considering this whole circular region, that this whole circular region be a sector which is forming by the angle theta, which is equal to 360 degree, right, at the center O, right? So now applying by the unitary method, if we apply the unitary method, we can arrive that the area of the sector OAPB can be calculated, right? Okay, so when degree measures of an angle at the center is 360 degree, right? So if we talk about this whole circular region as a sector, right, having angle 360 degree. So write down when degree measures, when degree measures of the angle at the center is 360 degree, then what will be the area of the sector? Area of the sector will be pi r square, right? Okay. So we are just considering this, that the circle is a circular region. It is a big sector having angle 360 degree, right? Then what will be the area of this sector? Pi r square, right? So now when the degree measures of the angle at the center is suppose 1, right? Then in that case, according to the unitary method, what will be the area of the sector? So by unitary method, when
We will be back in 2 minutes.
yeah, theta is equal to 1, right? Right. Here theta is 60 degree. Now suppose theta is means angle at the center is 1, then what will be the area? Area of the sector will be pi r square upon 360 degree, right? Upon 360, right? When theta is 1 by the unitary method, right? So therefore, when the degree measures of the angle of the center is theta, now suppose it is theta now, right? Then what will be the area? Area of the sector, right? So when angle is theta, when angle is theta at the center, right? Then area of the sector will be equal to pi r square upon 360 into theta by the unitary method. Is that clear? Right? Or we can write it down as area of a sector, area of a sector is equal to, you can take theta here and pi r square this side, theta upon 360 into pi r square. And this is how we get this formula, which is the area of the sector. Is that clear? So please write down. Right? So in this way, we can say that area of the sector is theta upon 360 degree into pi r square, where r is the radius of the circle and theta is the angle of the sector, angle of the sector in degrees. Okay, right. So now, as we have finded out the area of the sector, there is a question which can come into our mind, that can we find the length of the arc? If you can see here, we have a length. This is the length of the arc APB, right? So can we find the length of this arc APB corresponding to this sector? So yes, again by using the unitary method, okay, and taking the whole length of the circle as 2 pi r. Now this time we can also obtain this, the length of the arc, right? So what will be the length of the arc? So write down length of the arc APB, right, of this sector will be equal to theta upon 360 degree into 2 pi r. Exactly in the same way, right? Here it is theta upon 360 degree into area, because we are finding the area of the sector. Now we are finding the length of the arc. So theta upon 360 degree by the unitary method into the length of the boundary, right? Okay. So the length of the arc is actually the part of the boundary, right? So by unitary method, now we can write down that theta upon 360 into 2 pi r. And this will give you the length of the arc APB, right? So APB is the arc of the sector, right? Okay, so now we can find out the area of the sector as well as length of the arc of that sector, right? So now this is one other formula. Is that clear? Now, let's see this diagram again. If we join these points A and B, isn't it? Right. So what will happen? This chord AB, right, divides the whole circle into the major and minor segment, isn't it? Right. So what is the minor segment here? This part is the minor segment, right? This is the minor segment, right? And the rest of the part is the major segment, right? So if we take this case, right, we can also find the area of this segment APB, right? Okay, so how we can find the area of the segment? So write down area of segment APB, area of segment APB of a circle with center O and radius R, right? Okay, as we have already seen this on that figure, right? So how we can find it out? Area of segment APB is equal to area of the sector OAPB minus area of triangle OAB, area of triangle OAB means what is it? So look at here. Now in this figure again, area of the segment APB, right? What it will be? It will be the area of the sector OAPB, right? Means this smaller sector, right? Okay, minor sector OAPB. And if we subtract from this sector, if we subtract the area of the triangle, if we subtract this area of the triangle, we will get the area of APB. Yes or no? Right? So we have done the same thing here. So to find out the area of the segment APB, we have subtracted the area of the triangle AOB from the area of the sector, right? Now, what is the area of the sector OAPB? We have already calculated theta upon 360 degree. We are having angle theta, right? Into pi r square. This is the area of the sector OAPB with angle theta minus area of triangle OAB, right? So in this way, we can find out the area of the segment APB. Is it clear? Right? So area of the segment. Okay. Is that clear? Right. So now we can also write down that area of the major segment and minor segment, right, as area of the major segment, major sector OAQB. This is equal to pi r square minus area of the minor sector OAPB, right? So if we want to find the area of the major sector, what we will do? We will subtract the area of the minor sector from the total area of the circle, that is pi r square, right? So if we do so, we will get the area of the major sector, right? Okay. Now similarly, if we have to find the area of the major segment, area of major segment AQB, this is equal to pi r square minus area of the minor segment. That is APB, right? So in the same way, if we have to find out the area of the major segment, so then we will subtract the area of the minor segment from the area of the circle. Is that clear? So please write down. So I hope you're getting these concepts. Yes or no? Right? So we can find out in this way area of the segment, okay, area of the minor segment, area of the major segment, right? Similarly, area of the major sector and area of the minor sector, right? So, so we just quickly revise this, right? So if this is the circle, right? Okay, having, suppose this is the sector here, right? And if we join this is a segment, right? This is O, getting it? This is A, this is B, right? This is P, this is some point Q. Okay, radius is R and the angle is theta, right? So what will be the area of the sector of this angle theta, right? So what is the sector here? This whole is the sector, right? This whole is the sector here. Okay, and if we want to find the area, so we have just calculated this, that area of sector is, area of sector of angle theta will be equal to theta upon 360 degree into pi r square, right? Okay. Similarly, if we want to find the length of the arc, this one here to here, okay, arc APB, then we can also find it as area of, not area, length of arc of sector of angle theta, right? So if there is any sector theta, right, having angle theta, then what will be the length of this arc APB? This will be equal to theta upon 360 degree into 2 pi r, right? So these are the area of sector of angle theta and length of the arc of the sector angle theta, right? Now, as you can see here, that we have major sector and minor sector, right? So this one is your minor sector, OAPB. This is the minor sector, and this is your major sector. Getting that? Okay. So if we want to find the area of the major sector, how you will get it? Area of major sector will be equal to the area of the total circle, and if you subtract the area of the minor sector from it, we will get the area of major sector, right? So the area of the circle minus area of minor sector, this will give you the area of the major sector, right? So same thing we have done here. So area of the major segment, area of the major sector is equal to pi r square minus area of the minor sector. Is that clear? And vice versa. If suppose you know the area of the major sector, and if you subtract it from the total area of the circle, you will get the area of the minor sector. Is that clear? Right? Now, similarly, if we talk about the segment, right? So what will be the area of the segment? Now you can see here the area of the segment. Suppose this is your area of the segment. This is the segment, right? Okay, APB. So what will be the area of segment APB? Area of segment APB will be equal to area of the sector OAPB, right? Okay, minus area of the triangle, right? So what is the area of the sector OAPB, which is, we already know, theta upon 360 into pi r square, right? Minus area of triangle OAB, right? So if we subtract this area of this triangle from this whole sector, right, we will get the area of the segment, right? Now, if we suppose want to find the area of the major segment, now what is the major segment? This one, right? This part is the major segment, right? Okay. And now if we want to find the area of this major segment, area of major segment, OAQB, okay, this will be equal to pi r square, means area of the whole circle minus area of माइनर सेक्टर, ठीक है? तो अगर हम माइनर सेक्टर के एरिया को उसमें सब्ट्रैक्ट कर देंगे तो हमारे पास एरिया आ जाएगा मेजर सेगमेंट का, राइट? इज दैट क्लियर? माइनर सेगमेंट का एरिया सब्ट्रैक्ट करेंगे, देन वी विल गेट द एरिया ऑफ द मेजर सेगमेंट एंड द वाइस वर्सा, right? So this is the whole concept in this whole chapter, right? These are the total concept which we are going to apply now in the questions. Is that clear? Now, before doing the questions based on area related to circles, there are certain important things which we should know, right, about the questions, right? So just note them, okay? For rotation, for rotation of the hands of a clock, because the question we will be going to do, right, are based on, these type of things like hand of the clock, maybe sometime rotating wheels, right? Okay. So we should know these things about it, right? So the for rotation of hands of a clock, we should know that angle described by 1 minute, angle described by minute hand. Okay, there are two hands, minute hand and hour hand, right? So the angle described by minute hand in 60 minutes, in 60 minutes will be always equal to 360 degree, right? Second thing, angle described by our hand, described by our hand, okay, in 12 hours is also 360 degree, right? Another thing which we have to note is for rotating wheels, when there are questions based on rotating wheels, then the distance moved by a wheel in one rotation, okay, in one rotation means a wheel is taken one complete rotation, then it is always equal to its circumference, okay. Secondly, number of rotations, number of rotations in 1 minute. If suppose you have to find the number of rotations in 1 minute, then this will be always equal to distance moved in 1 minute divided by circumference, right? So if we have to find out like how much rotation the wheel have taken in 1 minute, then we will divide the distance, total distance moved in 1 minute. We will divide this with circumference. Then in this way, we will get the number of rotations in 1 minute, right? Now, the third important thing which we should know is when the two circles are touching each other, touching circles. Okay, so now in this point of view, when two circles touch, when two circles touch internally, okay, right? That means, suppose there are two circles like this, one is like this, okay, and another is inside it, and they are touching like this. Is that clear? Okay. This is suppose O, and this is O dash, and this point is P where they are touching, right? So when two circles touch internally, right? Suppose this is figure 1, right? Okay. Then the distance, then the distance, their distance between their centers, this will be equal to the difference of their radii, will be equal to difference of their radii. Is that clear? Right? That means this distance between their centers means this to this. Okay, this will be the difference into their radii. If we subtract their radii, OP and O dash P are the radii, right? So if we subtract them, subtract them, we will get this distance OO dash. Okay. Now, second point, when two circles touch externally, when two circles touch externally, right? Means now this time the circles are like this. One circle, another circle, and they're touching like this. Okay. This is O, O dash, O and O dash, right? And the point where they are touching each other is P, right? So when two circles touch externally in figure 2, so suppose figure 2, then distance between their centers, distance between their centers will be equal to the sum of their radii, right? So if we add their radius, we will get the distance between their centers. That means what? What will be the distance between their centers? We will add their radii. So if suppose this is the radius of one circle and this is the radius of another circle, then if we add them r plus r, then we will get the distance between these two centers. Is that clear? Right? So if we want to find the distance between the two centers of such circles which are touched externally, then we add their radii, right? And if the circles are touching internally as is shown in the figure 1, then the distance between their center will be equal to the difference of their radii, right? So these are some important things which we should note, right, before solving the questions related to this chapter, right? So now in the next class, we will discuss some questions based on it, right, which are given in your NCERT as well as other questions also.